multiplying and dividing rational expressions are actually pretty straightforward. If you didn't like fractions, you might like this, multiplying fractions. And so I've shown a couple of examples up there of how we used to multiply fractions. It's just numerator times numerator and denominator times denominator. 2 times 5 is 10, 3 times 7 is 21. There is another step, though. This one worked out to -6 over -28, which first I canceled the negatives, but then I common factored out a 2. That's maybe not the way you thought about it. I common factored out a 2, and that canceled, and I got that down to 3 over 14. Just remember that when I go to later examples, that the factors can cancel. So the final sentence of this first slide says, rational expressions are multiplied in the exact same way, and give it a chance. Give fractions a chance this time. You'll have lots of chance later in the chapter to hate adding and subtracting rational expressions. So you can keep your hate going for fractions, but just save it up. It's not here. It's not today. Simplify and state the restrictions on the variables. Okay, this goes the same as what we just did. The first one is w over y, w over x times y over z. Like yesterday, first state the restrictions, comma. X can't be 0, z can't be 0. Next, numerator times numerator, denominator times denominator. That's the same as what we were just talking about. The top is wy, and the bottom is xz. All we're going to do now is check for cancellations. Is there a w in the denominator? No. Is there a y in the denominator? No. So there's nothing to cancel. We'll try to simplify at the end. So technically, you really should state the restrictions here again. But I'll be so happy to see them. If they're up at the top, I'll be like, oh, that's not technically where you're supposed to put them, but I'll take it. Question?
I still don't get the how you're saying that a variable it can't equal 0.
You can, the values of w, y, x, and z can be anything you want. Go ahead, sub in anything you want. 1, 2, 3, 4, 5, 6, 7, 8, whatever the numbers are. As we go in and do applications, you'll be able to use whatever numbers you want. Yeah, but this is warning you. It's just a warning. If x is z or z, sorry, if x is 0 or z is 0, this expression will come out to undefined. You won't be able to divide by 0. You won't be able to use this.
Oh, so it's saying if it says if x can't be 0, but if x is 0,
then don't use this. It's not going to work.
Oh, because I thought you were trying to say that it just x couldn't. It's impossible for x to be 0.
No, x can be 0.
Oh no.
But x can be 0. But if x is 0, you can't use this expression. You're going to get divided by 0. Good. All right. As math lessons like this are fun. They start off with, I think, something where it's like, okay, I get that. And then it just ramps up using stuff you've seen in previous lessons. So for instance, this one. Again, start off by stating the restrictions. X, comma, y can't equal 0. So here's a shorter way of saying that. I like this, but you can also go, you can list them like this as well. You go, well, x and y can't be 0. If x is 0, this denominator is going to be 0. If y is 0, this denominator is going to be 0. So that's still going to be the same thing that you were doing last night. State the restrictions. Then, numerator times numerator, denominator times denominator. And if you're right with me, you're like, oh, this is the chapter we just finished. That's why we went through that chapter, was so that when we had to multiply these expressions, we'd know what to do. We'd know to add the exponents, or subtract the exponents, or multiply the coefficients. We'd know how to handle that. Which, by the way, when you get your test back later, if it's really bad.
Oh, we're getting it back today?
Yeah, I had it yesterday for you. We just ran out of time. And it's not what you wanted. Know that this chapter continues to practice all those skills. Plenty of 11U students do well in a rewrite of Chapter 1 somewhere down the way after they've got a chance to practice this stuff. So it's not time to freak out or give up, and I'll talk about that later. Okay, the only thing different here, well, it's not different. I did it, right? When it was -6 over -28, I didn't stop. I went, now can I simplify? And this is the exact same. Can I simplify? 30 over 18. Is there a number that divides into both 30 and 18? 6. That's good. If somebody had said 3, that would have worked, but then you would have had to do it again. But if you divide by 6, I get 5 over 3. And do you see, I talked about this yesterday with that weird spotlight tool. See how I'm thinking about it? I'm not thinking about the whole thing. I'm not letting my brain get all messed up by this massive amount of algebra. I'm just going, oh, 30 over 18. Let's just talk about that. We've done fractions before. Divide them both by 6. Now, x cubed over x squared. Subtract the exponents. And I just get x to the 1, which I'm just going to write x. Because it was a positive exponent, it stays up in the numerator. And then y cubed over y squared, y. You really should state the restrictions here at the bottom. So I'll keep doing that here as well. Now, the reason those ones were so easy and not really what we're up to today is none of these things, these things were already completely factored. That's going to be the big thing. As soon as you see a question, you're like, whoa, 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 whoa. I don't know if I remember the rules for multiply or divide or restrictions or anything else, but I better get it in factored form first. And I'm just going to zip back to the calculus lesson. From today, I didn't rig this up. I just noticed while I was teaching calculus today that that's what they're doing too. Do you see? They immediately factor. Did they have a little bit tougher factoring than you? Maybe, but they immediately factor. That's what we did today. Then we started to talk about what the heck is going on. Okay? So we're doing calculus here right now. We're getting ready. We're doing all this course often, these two courses, 11 and 12, are sometimes called pre-calculus in the US. Is that just like, we're just getting ready for calculus, that's all we're up to. And then it helps to know, oh, some of this stuff I don't have to understand why we're doing these things. I'm just getting ready to take calculus. Okay, so factoring.
What, I have a question.
Yeah.
Is calculus like a kind of math you can take, or is it like...
Yes, in grade 12, you can take calculus after taking advanced functions, or you can take data management. They are two completely separate branches of mathematics. Data management is like statistics, mean, median, mode, stuff like that. Really meant for biology, psychology, those type of things.
What's advanced functions?
Advanced functions is the true pre-calculus course. Really, it's just part 2 of this course.
Oh. Why do people say why do people say calculus? I don't get it.
The 3 courses are, in order, grade 11 functions, grade 12 advanced functions, and then grade 12 calculus. Those are the 3 courses in order.
Oh, okay.
All right, here's the checklist. And again, if you go back to my video on factoring, I did my best to lay this out as steps. 1, is there a common factor in the numerator? No. Is it 2 terms, which might make it a difference of squares? No. It's 3 terms, but the a value is 1. The leading coefficient, the coefficient x squared is a 1. That type of factoring is probably not the one that's going to give you a headache. Because all you got to do is go, what multiplies to -6 but adds to +1? Let's make the list. Here's all the things that multiply to -6. 1 and -6, 2 and -3, -1 and +6, -2, +3. Which of those pairs adds to +1? No.
2 and 3.
-2 and +3 add to 1. This type of factoring has a very specific procedure. Just find all the pairs. Now, somebody last year finally told me, I don't like doing the ones that multiply to this. I do the ones that add to this. I find that more difficult, but maybe that's the way to go. You go, okay, what adds to 1? 2 and -1, 3 and -2, and maybe that's the way to approach it. But it's really a systematic approach. Find all the pairs, and then find the pair that actually works. X minus 2, x plus 3. Now how about the bottom? 2 things that multiply to -15 and add to 2. 5 and 3. Again, any multiplication table work you do pays off here. So get an app that does flashcards for multiplication tables, and the more of those you can be a little bit better at, the faster this will all go. X plus 5, x minus 3. I don't have a lot of sympathy for people who make mistakes on factoring, and not because I'm like, oh, you should have done your homework. That's not what I mean. What I mean is, you can check the answer right here. You can FOIL it out, and even if you get the wrong 2 numbers, you can just quickly go x squared, 3x minus 2x, yep, -6, and you just multiply it out, and you go, yep, it's right. Now, factoring, then state restrictions. I'm going to change colors here, state restrictions. X can't equal -5, +3, and 2. Don't let me go on until you see where I'm getting that from. That's fairly easy to pick out. You're just picking out the x values that make the denominator 0. Next, we're multiplying, so numerator times numerator, denominator times denominator. So the numerator is x minus 2, x plus 3, and x minus 3. And the denominator is x plus 5 and x minus 3. So far, you're unimpressed. You're like, okay, so you just wrote it all together on one fraction? Yes. But now I can check for any cancellations that occur. Is there any factor that's in the numerator but also in the denominator? Oh, I forgot one. Is that why? I see a couple of you frowning at me. There, yeah, good. Is that why you're frowning? Yeah, good. I saw the frown. I tried to finish the next step to see if I was going to fix it, but no, I forgot one there. So what's in both the numerator and the denominator? Do you see anything the same? X minus 3 goes, and also x minus 2 goes. You're like, you rigged that up to happen. Well, yes, I did. However, I'm going to show you the calculus note from today. I didn't rig it up. I didn't grab something from a textbook off, blow the dust off, and go, look, we're going to cancel. I'll show you the example from today in calculus. So this comes x plus 3 over x plus 5, and x can't equal negative 5, 3, and 2. You really should state the restrictions at the end there, so you let everybody know. Now, why are we doing this? First reason. It's much simpler. Look at the original expression. Look at the new expression, x plus 3 over x plus 5. That's a good reason to do it. It's just to simplify things down, and you future computer coders, we always want to use the simplest code we can. But there's more to the story coming. By the time you get to calculus, here's the calculus lesson from today. We factored and canceled so that we were able to do the next step. Okay? So that's why it matters, is because we're going to continue on after we've done the cancellation. So we're right in the middle of the story right now. It's like you've watched the first 3 episodes of a season on Netflix, and you're like, I don't know what's happening. I don't know who that is. Why is that guy? Yeah, 11 U's like that, where it's like, I don't know why we're doing this. It's because we're only partway through the story. Dion. Yeah. We subbed in. This is calculus now, nothing to do with what we're doing. When I sub 2 into this thing, I got 0 over 0, and that's a trigger in calculus to go, oh, better see if it factors, because it was 0 over 0. So there's more to the 0 story yet. I'm just starting the 0 story. And our 0 story for now is the restrictions. Can't equal 0 in the denominator. Later on, we'll learn, oh, there's more to this story. There's more to talk about here. All right, any questions about C? Okay, there's a definite procedure here. Factor, restrictions, cancel. Every single time. Factor, restrictions, cancel. In this case, I was multiplying, so I needed numerator times numerator and denominator times denominator. So there it is. Plan of attack for multiplying rational functions, expressions. And even if you're not copying down these lessons, which is absolute insanity, you're going to want this. And those of you who are copying this down, this gets your highlighter. You break out the big highlighter and go, this is what I'm looking for. For instance, if you Saturday morning get up, have scrambled eggs and bacon, then go, you know what, I'm going to get to that homework. Mr. Todd's convincing me that's the life I have to live now. And you get to the very first question of this homework and you go, I don't know how to do it. And you text it to me, Mr. Todd, I don't know how to do the first one. I will answer. And I'll say, why don't you try factoring first? But in my mind, I'll be thinking, I'm not getting through to them. I got to do a better job of going, these notes matter. I know all this stuff. The notes aren't for me. They're my Christmas gift to you. Go here. If you're having trouble with the homework, look at my beautiful notes. They tell you what to do. And right here especially, this part of the note is huge. What's my strategy? Factor first, then state the restrictions, multiply the numerators and denominators, do any cancellation you can, and then state the final answer with the restrictions. Am I going to take a half mark off if you don't state the restrictions on the bottom line? Well, no, I guess I won't. I'll be disappointed, But as long as the restrictions are somewhere, I'll live with it because there's more important math to be talked about here. But that's where it should be done. I'll pause while you copy. In some ways, the most important slide of the day. It tells you exactly what to do. Many math people like stuff like this, where it's like, there's a procedure. I don't have to sit there and go, what do I do here? Oh, it's multiplying. I do this, 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 and this. And Nathan's using his brand new highlighters. Are those, is that the new set? I have more. And I'm about to do a Staples order anyways. Where are they? Oh, I got a whole bag of them. Let me know if you want to be a highlighter person. This is the power I have. Ordering things whatever I feel like it. You iPad people are like, I don't know. I got built-in highlighters of every shade there is. More time here? Let's talk about dividing. Dividing rational expressions. Who's with me? Who's got this? This is going to change what we're doing this much. Yeah? Just my fingers are as close together as I can get them. It's going to change what we're doing just a tiny bit, but we need someone who remembers what you do with divided fractions. Nathan? You flip the second one and multiply. And once you do that, you can just do what we were already doing. That's all you got to know. That's the only dividing fractions thing you got to know. 14 over 15. Once you flip it and multiply, I don't have to teach you anything else. I mean, if I was a lazy teacher, I might do that. I might right there go, okay, if it's dividing, just flip the second one and multiply, okay? Have a good day. Enjoy your weekend. Yeah? Okay. Well, I'm not going to do that, of course. I'm going to do a couple examples. But that's basically what I'm up to. Rational expressions are divided in the same way that fractions are divided. There's going to be a new procedure for dividing fractions. And I'm going to come back here again if you haven't copied it, but it's going to look just like this one, except it's going to say flip and multiply. That's all. It's going to look the same. Yeah. Hey, hey, what's the matter with you? Hey, hey. This one didn't happen to reduce. I'm going to change this example next year to make it so it reduces when it's over. Yeah? This one doesn't reduce. But, yeah. Do you need more time here? Who needs more time? You do need more time? That's okay. I'm working hard to get through to the non-copying people. People aren't copying this down. If you really don't like copying down, then print the note. What would you have to copy down on this page if you printed the note beforehand? This, 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 and this. It's not the best way to learn. The best way to learn is to copy down the things I'm doing. It helps you to understand what's happening. But if you really don't want to do that, at least print the note and copy down the fill-in parts. Yeah? Did I give you enough time? There, found all my stuff. Good. Simplify and state the restrictions. Don't worry about what's in the box for a second. You're going to have to copy in a second, but don't copy it down right now until I need someone clever to help me with one example. Something weird is going to happen here with dividing. I said dividing was exactly the same, and I will stick to that. It is exactly the same. We state the restrictions. X, comma, Z can't be equal to 0. Do you see them? You can't divide by 0. State the restrictions. Factor if you can. There's no factoring to be had in this question. So then the thing you have to know with division is that becomes W over X times Z over Y. Again, I could have just sent you home and said, go home and do that. Dividing fractions is multiplied by the reciprocal, and so what I get here is equals WZ over XY. You're like, now I feel like you're wasting my time, Mr. Todd. That feels a lot like what we were already doing. And it is, except for one little thing. Y can't be 0 now too. So there's a second time you got to check for restrictions when dividing fractions. Something that didn't look like it mattered, this y up here, actually we were dividing by that as well. So actually the restrictions are W, no, not W. The ones I already had, X, Z, but now I've noticed, and you could notice it earlier, it's possible to, but most people, they go, oh, I noticed that in this question where Y also can't be 0, we can also not divide by Y. Nathan.
How come Y wouldn't have to be if you flip it?
If I subbed in,
Z.
yeah, I'm with you. If I subbed in 0 for X, then this becomes undefined, and then I can't do the question. If I sub in 0 for Z, then this fraction becomes undefined. You do, but this is saying divided by Y over Z. So at some point in the question, it is divide. Yeah? So it's like you find out it's a much deeper rule than you think. Don't divide by 0 anywhere, anytime, anyhow, even though the algebraic procedure here gets rid of that. Is there something more to understand about the situation? Yes, you're tripping on here where X can't equal 2, but we subbed into. Lots to talk about. Like a whole nother course, advanced functions, before we get there. But for us, we're okay here right now, just going, okay, apparently X, Z, and Y. We had better at least put some thought into them. Let's say that for now. Okay, here's another one. No factoring, so immediately state restrictions. Z can't be 0. That's the only restriction I see there. And if you're really clever, maybe you can already look and see where the other restrictions are going to be. And that's fine. You can do that if you want. But here's the procedure. 2xy over 5z multiplied by 15z squared over 14x squared y squared. I'll draw a line. That's how I organize myself when I want to use more of the page. Then I actually go numerator times numerator, denominator times denominator. Don't let me away with it if you don't understand what I did on the top there. Well, first of all, that's wrong, so maybe that messed you up. 13xyz squared over 70x squared y squared z. Please look at that long enough that you go, oh, I get that. X, y, z squared, x squared, y squared, z. I changed the order to put them in alphabetical order. It's not an algebraic requirement, but it is going to help you stay organized. So alphabetical order is the better way to go with variables. Now reduce. Now there's two ways to do this. It could be, when you see me do this example, you look and go, oh, I like the new way. So I'll do it the old way, the way I talked about before, and then I'll show you a different way to think about it that might help. 30 over 70, 3/7. X over x squared, subtract the exponents so I get x to the negative 1. Y over y squared, y to the negative 1. But z over z squared over z is actually z, and I finish this question off by going 3z, over 7xy. Because the x and y had negative exponents, they move down to the denominator. If you're getting good at it, though, you might look at it and go, oh, I could have figured that out beforehand. X squared and x, one of the x's cancel, and what I'm left with is an x in the denominator. That's all that's going on, is the denominator won the cancellation battle. That's what a negative exponent means, is yes, there's one x left, but it's down in the bottom, not in the top. Last thing, restrictions. For me, now I just scan down the whole page and see what happened. Yes, at the start, z can't be 0. Then later on, x and y joined the party. So also, x and y can't be equal to 0. And at the end, it was just x and y there. But along the way, we found out z can't be 0. Even though z canceled, it also can't be 0. So you have to scan down all the denominators when you do the restriction at the end. Maybe that's why we say do it at the end. And that's what says in the box. When stating the restrictions, don't forget to consider the denominator of the second fraction before it was flipped, values that can cause the second expression to be 0. That's a technical way to say it. What I would say is check all the denominators in the question for 0. I know some people want to copy what's in the box, so I will hesitate for a second so you can copy what's in the box. With 2 slides to go. We're in great shape today, hopefully. Well, I haven't seen the last 2 slides, so maybe. Oh, one of them's the instructions. That won't take long. That's just you copying. Do you need more time there? Yes. Good. That's okay. I'll just do my cube. I don't care.
I was actually with that
This is like the easiest lesson.
It might be.
last night.
This is just like, it's just simple. It's like,
Maybe. As long as you can factor.
I can factor very easy. I'm very good at it.
All right.
Genius.
I don't know if the Genius scale has factoring on it, but that's good.
Yeah, I guess.
It's like huge.
Let's see. Let's see. Oh, who's that guy?
More time? Yes? More time? It's okay, Hazel? Which part? Oh. Do you want we can rearrange if you want. We can move your desk closer if you're, okay. Again, and even when you get here, I'll put one right there for you that you can have during the lesson. In fact, I'll do it right now if you want to change right now. And the reason I say it just like that is I have a son who was the exact same way. Would come to my class and squint at the screen until I yelled at him to just come sit at the front at the start. There, that's for you, Hazel. Welcome. Sydney, same thing. If you want to pull up to there, whatever you need to do. Extra examples, and then the procedure. Yes, okay. 2 examples, and then you'll have some copying to do of the procedure. Ooh, here we go. There's the tough question from the homework this weekend. That's one that's got it all. What's the first step in the procedure? Oh, yes? Yes, yes. Common factor if you can. But in the procedure for dividing rational expressions, we're going to factor first. And the first step in factoring is to look for a common factor. Please, numerator, have a common factor. When you see that 12 in front of x squared, you're like, oh. I hope it has a common factor. It doesn't have a common factor. So that thing is going to need to be factored using one of the 2 advanced methods, which I'll do separately. I'm going to jump to a separate page and just go after the numerator, okay? And here it is. I think it'll be on 3 videos in a row. How to factor it when the a value is not 1. So what was it? 12x squared.
I'm going to read it to you.
Yeah. Minus 9.
19x plus 5, and then the numerator, or the denominator found 4x squared minus 5.
I'll come back to that one.
Okay.
I'm just going after this one because this is the one I think is going to slow you down. The other 3 methods, with a little bit of practice, you'll probably be okay. This is the one that usually stops people cold. All right, so first I'm going to try to prove it can be done by using your brain, and then you decide for yourself whether it's like, no, I sort of like using my brain. And by use your brain, we don't mean like the way your mom talks to you. Oh, come on, use your brain. That's not what I mean. I mean just like, no procedure here, nothing going on. We just look and go, okay, 12x squared minus 19x plus 5. If that's 12x squared, the first 2 terms could be 4x and 3x, to which you're like, well, it could be 6x and 2x. I'm like, I know. I might have to use my brain a lot here. Then the last 2 numbers could be -5 and -1. If I put it -1, -5, does that work? That's -20, -23. No, that doesn't work. I'm going to try -5, -1. That's -15, -19. Done. Okay? That went fast on purpose, but basically the strategy is play around with the numbers until you get this thing to FOIL out. Now I can see some of you frowning or sneering. By the way, sneering at me, I have 2 daughters. Like, sneering at me is not going to affect my day at all. I get sneered at more than anybody, you know, and they're the perfect ages, 10 and 22. There's a lot of sneering going on at my house. Anything I say, they're looking at me like, yeah? So a lot of sneering about that procedure. If you don't like that, you might love this. This is called decomposition. If you want to look it up, it's been in 3 videos in a row. But before you leave for the weekend, let's really talk about it. Decomposition says find a value for AC. And by AC, we mean take this first number and multiply it by this last number. In this case, it's 12 times 5, which is 60. That's my target number. So I list all the things that will multiply to 60. Do you need all of them? No. I'm only doing that to really teach it this time so you can see what decomposition is all about. All the things that multiply to 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that's all of them. Do you need to write them all? No. You do not need to write them all. It's just me teaching.
Hello, Mr. Todd.
Hi there.
Is Peyton Clunder in class?
Yes?
Could you come to student services, please?
Gladly.
Thank you.
One of these will add to 19. Ah, 19. 19. I'm looking for the pair that adds to 19. Now here's the weird part about decomposition. I use that to take the negative 19 and break it into negative 5, negative 14. Notice that it was actually negative 4 and negative 15 I needed there. Okay? Right now, it all seems very mysterious what I'm up to. So let me explain what I'm up to. I've now found out when you FOIL out the brackets what the FOIL will look like. This first step of decomposition showed me the 2 magic numbers that were in the FOIL. Now you can look and go, okay, if that was what was in the FOIL, then what was in the first term? I common factor 4x out of the first 2. I common factor negative 3 out of the second 2. And if you've done it right, or sorry, negative 5 out of the second 2, you end up with the same bracket in both. And now you can see the 2 pairs. 4x minus 5, 3x minus 1. Oh, I see a couple look on your face. You're staring at that like, really? Are you joking? That's what I have to go through every time I want to factor one of these things? And the answer is yes. Really. Absolutely. That's what it takes. They're not as bad as they seem. This procedure, I've seen people do decomposition who weren't particularly good at mental math, but they just practiced decomp until they went, it actually gets a short form, it's so popular. Oh, I'll just do decomp on that. That's the way math people talk. And you can actually nail this down and make decomp happen fairly quickly. Decide for yourself whether you're a use your brain person or a decomp person, and practice it enough that you feel confident. It's not going away. It's not going away. It's not like, oh, you know, we never ended up using that. That's not what's going to happen here. We're going to use decomp all the time. Or use your brain. My calculus students are used to me just doing use your brain. And if they do decomp, they can go ahead and do decomp on their own. Okay? Any questions about that procedure? It's a little magical. Question?
You're just finding something that multiplied to 16 and added to 19?
Multiplied to 60 and added to negative 19. So that in that way, it resembles the other procedure a little bit. But here, once I find those 2 numbers, I'm using them to break up that negative 19 into what it was before it was FOILed. How does it accomplish that? Well, someone clever has figured out that the 2 numbers that multiply to AC and add to B are the 2 numbers that got FOILed out. Okay? It's perfectly legitimate and not magical. It's not a trick. It's just someone with deep understanding of FOIL came up with it. If you've ever seen Magic X before, Magic X is decomposition. It's just a different way of organizing how you do it. So if you like Magic X or if you see Magic X online, that's fine. It's decomp with a different way of writing the numbers, that's all. Do you have any questions? That's in 3 straight videos now. I don't mean that like like I'm mad or something. I mean that like you got 3 different places you can look for the explanation. I think my last one was the longest one. So, factor first. Okay, now the denominator. Let's go through the checklist. If this looks mysterious to you, let's go through the checklist. 1, is there a common factor? Is there something that divides into 4 and into 9? And the answer is no. Is it 2 terms? Yes. With 2 terms, we're looking going, maybe it's a difference of squares. Is there something you square to give 9? 3. Is there something that squares to give 4x squared? 2x. Difference of squares is the easiest of the procedures. That's the only thinking you have to do, because now I look and go, okay, that means this is 2x minus 3 and 2x plus 3. I didn't say difference of squares was easy. That is not what I said. What I said is it's the easiest of the procedures. Of the 4 of them, when you see difference of squares, it often happens very, very quickly. Now, state restrictions. X can't equal 3 halves, negative 3 halves, or 3 halves again. But I'll show that up here if you're like, how did you get those so fast? Well, I've been here too long, probably. But what I did is I said, okay, 2x minus 3 can't be equal to 0. Brought the 3 over and divided. So when there's a coefficient there, maybe you got a couple extra steps in your restrictions. Are you with me? What's next then? State restrictions? Dividing fractions? Yeah, flip. Multiply by the flip, the reciprocal. 4x minus 5, 3x minus 1, 2x minus 3, 2x plus 3, times 2x minus 3 over 3x minus 1. Then look for cancels. Oh no, actually multiply numerator times numerator, denominator times denominator. I could do the cancels now. Did you know that? I could cancel now. I don't have to actually get it all under one fraction, but I'll show it. 4x minus 5, 3x minus 1, 2x minus 3, 2x minus 3, 2x plus 3, 3x minus 1. Get my blue pen out. Look for cancels. 3x minus 1 goes. 2x minus 3 goes. And I'm left with 4x minus 5 over 2x plus 3. For us, that's a way simpler expression than that mess I started with. But moving forward into calculus, then we'll be able to do something. So the story isn't over yet. We're like halfway through a season at this point. Yeah? And so I state my restrictions. Gonna make a mistake here. Somebody who's right with me can correct it. X can't equal 3 halves, negative 3 halves. But there's another one that's popped its head up in the middle of all this. What's the last restriction? This one's okay. That one's I already have. But there was another thing in the denominator. Go back to the denominators. I dealt with that denominator, dealt with that one. There. There's the, so I'll just give that a little highlight. There's the extra restriction that appeared there, and that's a 1/3. Question?
Could you reduce that even more though?
No, but I know what you're thinking. So ask your question a different way. What do you think should be able to cancel here?
The 4x and
The 4x and the 2x can't cancel because the 4x is being subtracted. It's not multiply and divide, but it's a great question. It is the mistake people will make. They'll go ahead and cancel 4x and 2x when it's not 4x divided by 2x. It's 4x minus 5. So that was that weird sentence I said on the first day. I'm like, if you multiply and divide first, if that's what you're doing, is multiplying and dividing, if those are happening simultaneously, then they can cancel. Here it's not happening simultaneously. Good question. Here's what I'm going to do. I'm going to use my grabber. I'm going to grab all that and and make it a little smaller so that maybe I can get back up to this one. Did it work? It did work. Okay, very intimidating, but exact same question really. Factor, factor, factor. Which, okay, there's 4 factors to do. Which one's the easiest one? Is there an easy one in there? If you were going to factor these, which one would you go after first? X squared minus 6x. You go through your procedure. You go, is there a common factor? Yes, there sure is. See how that doesn't confuse with difference of squares because you checked common factor first. And then these other ones, okay, if you don't like when the a value is some number, yes, you're going to have to practice that. But these ones have to become automatic, but they go pretty quickly.
X squared minus x minus 20.
Okay, you like that one? Go, tell me.
It'd be x minus 5x plus 4.
The hesitation is exactly what we need. If you hear the hesitation in his voice, it's because he's going 4, I know it's 4, 5, is it minus 4? Yeah, exactly right thinking. And then x squared plus 9x plus 20. X plus 5, x plus 4. Oh, this one though. 2 things that multiply to 36, but add to negative 12. 6 and 6. So I'm going to write it as x minus 6 times x minus 6. But if you wrote it as x minus 6 squared, that wouldn't be wrong either. Those ones, all the factoring in that question, at least get that to be easy. If you struggle with these and these take you time, then the one in the numerator over there, okay, that's a work in progress, but those ones have to start getting faster. So now state the restrictions. I'll change colors. X can't equal 0 or 6. And I'm going to multiply by the reciprocal. And I'll show you a little shortcut on these questions, save you a line of algebra. Once it's multiply, you don't have to do the multiplication right there. If you want, you can consider this all one fraction, and you can do the cancellation right there once it's multiply. That is, I can get the negative 6's to go. One of the x plus 4's to go. Or sorry, one of the x minus 6's to go. And one of the x minus 6's to go. And then I'm left with the numerator's x minus 5, x minus 6, and the denominator's x and x plus 5. I had my old restrictions. X isn't 0 or 6. Nobody wanted to answer the last one, but is there other restrictions that have come up in the meantime? What else ended up in the denominator eventually? Negative 5 and negative 4. Even though it canceled, it's got to be a restriction as well. Anything that was in the denominator at some point in the question. Must factor, folks. Must factor. Must factor. It's not going away. It's worse even than you think. Next week I'll do adding and subtracting, and the first step will be factor, and the first step will be factor. You know, if you can't factor, this will be the biggest train wreck test of your life. Like 1 out of 56 or 5 out of 56, you know, some ridiculous number. Now, before you get too scared, most people, the first 3 steps of factoring, they're pretty good at it already. They can, the first 3 kinds. It's this kind right here, and so this gets the orange highlighter. I'm not going to use red, but this one gets the orange highlighter like, okay, come on, this weekend, either decomp or use my head, I'm going to nail this down, and this chapter will start to get better. Do you need more time there? There's only one more slide, which I'll read, and then leave it on the screen for you to copy while I start talking about tests. No, that's not true. I'll give you time to copy it, then I'll talk about tests. I can't see what's happening. There it is. More time? Is it okay? Okay, so here's the procedure if you need it. It looks exactly like the multiplying procedure. Here's the plan of attack. It's the only way it's different. Look at all these lines, it's the exact same as the multiplying one. Factor first, state restrictions, multiply the first expression by the reciprocal. That's different here. When you're dividing, that one is different. But you also have to add any new restrictions. So 3 and 4 have a slight quirk to them when you're dividing instead of multiplying. Most of the stuff's the same that you're going to do here. But 3 and 4 have a little bit to them. If you like procedures, then you're really going to want that down to go, okay, here's exactly how I do these. You can text or email me, that's fine. But start using the notes to help you a little more. Oh, that's wrong. Silly rabbit.
How many more slides are there?
This is it, buddy. Copy this one down and then you're done.
I did it.
Kyle, why would you even ask if you're not even gonna
Listen,
That's what I was trying to say.
I got like good hearing, good memory.
No, you
I guess you'll find out when you get your test back if you do or
I
not.
actually have terrible memory, and I know I did terrible on that test.
Then I suggest you change your strategy.
Yeah, I guess. Most times, like when teachers say you have to copy the notes down and like do homework or
Not I guess.
like you're gonna like.
I'm not sort of good at this. That is not what I'm doing. I'm not sort of good at getting you on track. Somewhere along the way, you're going to be like, here's what I'm going to do from now on. Exactly what Mr. Todd says every single time. He's been doing this 5 years longer than I've been alive. Let that rattle around.
No, not 5 years.
How old are you?
16.
When you were born,
4 plus 3 is 7.
when you were crapping in your pants, I had already been here for 7 years.
Yeah, so 7.
Good.
No,
Oh,
no.
good, correct. Oh, because that's the point.
I mean, simple addition.
Did you see it? It went right on by the point. You missed it. It went right by the windows there.
So you went to your 28 years, but you don't know some simple subtraction.
You're going to make fun of my simple subtraction after that test you just had?
I'm just